Hi everyone, my name is Ruijie Wang. I'm glad to be here to present the TiiS paper titled Modeling Dyslexic Students' Motivation for Enhanced Learning in E-Learning Systems. As a brief self-introduction, I'm currently working as a postdoc at Bournemouth University. My PhD project was focused on motivation modeling and computation for people with dyslexia at De Montfort University. I have a background of both HCI and psychology. This work I'm presenting now is part of my PhD project. This is the outline of my presentation today. First, research background. Today, e-learning systems offer us the opportunity to monitor users during their learning process, such as behavioral and mental states and learning progress, in order to apply personalized learning services and strategies to assist users' learning. Highly motivated users are more likely to respond more interactively with the system, stay longer in the system, and thus gain a high level of involvement and understanding of learning content in e-learning systems. Those with learning difficulties, such as dyslexia, specifically, are more likely to suffer from frustration and lack of motivation due to the difficulties they experience frequently in learning process. This is why we should incorporate motivational factors into user modeling and personalization in e-learning systems for such students with learning difficulties. As a first step, we want to investigate what are the key motivational factors that affect dyslexic students' continued intention of using e-learning systems, and how to quantitatively model motivation with these factors. This is the aim of the present paper. After this, we can then explore the computation method to assess users' motivational states that are dynamically changing during the learning process in order to apply personalized strategies to e-learning systems. Methodology. The approach is to initially construct the model by integrating the most relevant factors from existing theories with modifications to adapt to our research context. Following that, an empirical study was conducted with dyslexic students to identify the relevant factors in real-world scenario and refine the initial model accordingly. This process is mainly knowledge-driven and qualitative. Afterwards, we constructed a multi-item questionnaire according to themes resulting from the qualitative modeling stage and applied structural equation modeling to quantitatively test the effect of the motivational factors and determine the interrelationships quantitatively in the model. Qualitative motivation modeling. We conducted an empirical study by remotely observing a sample of 11 students with dyslexia to use a prototype of mobile learning system called MuteTime, followed by individual interviews. The study intended to collect first-hand data from dyslexic students about all possible motivations and barriers to use the software. The software provided a concrete real-world context for this study. Each participant did 4 learning tasks with quizzes in the software. Each is less than 15 minutes with learning content made of text, audio, and video. In the meantime, we also compared 2 features of the software that may be important to dyslexic learners. Some users were allowed to have the learning content read aloud by clicking on a button on the learning interface, but the others could not do that. In the quiz, users received feedback in the software showing whether an answer is correct or not. In the interviews, we showed participants an alternative version of feedback with prototypes with levels and badges showing their task performance, as shown in this picture. In the interview, they were asked open-ended questions about their learning experiences to elicit their motivational factors and barriers to use the software and continue the learning process in the software. Using paper coding and semantic approach, Profiles are generated for each participant, containing their reasons for intention to use the software and their demographic information. User motivations revealed for each participant were then related to corresponding motivational factors retrieved from the literature. If no match was found in the prevailing literature, a new theme would be proposed. Secondly, the interviews transcripts were coded and analyzed using qualitative data analysis software called Enable to improve the reliability of the analysis and enhance the objectivity of the findings. Based on motivation themes revealed in the qualitative study and based on existing theories and research in literature, these factors and relationships between the factors were proposed and incorporated to refine the initial motivation model. Next step is a quantitative motivation modeling stage. We developed a series of statements on multi-item questionnaire according to the themes identified from the qualitative modeling stage. To examine the motivational factors and quantitatively examine their relationships. Participants were asked to assess the statements on 5-point Likert-type questionnaire, ranging from strongly agree to strongly disagree. The questionnaire was reviewed by experts and pre-tested by Dyslexic students and refined accordingly before distribution. Data gathered were analyzed using structural equation modeling. There are two typical approaches to SEM, namely covariance-based or variance-based SEM, also namely CB-SEM or PLS-SEM. We firstly used CB-SEM, but we found our data does not fulfill normality assumption. Also, our sample was relatively small, 88 respondents. So we also use the PLS-SEM to consolidate the results by examining if there's a huge difference between the two approaches. The objectives of the two approaches are exactly the same. First, to ensure the reliability and the validity of the measurement model. Second, to examine the statistical significance of the paths in the structural model. So measurement model refers to how measured variables come together to represent constructs. Structural model involves how constructs are related to each other. Exploratory factor analysis and confirmatory factor analysis were also performed to test the validity of the measurement model. Results. This is a motivation model resulting from CB-SEM, showing how different factors work together to influence continued intention to use an e-learning system. All paths between factors were significant, showing path coefficient, which is the standardized beta. And this is a motivation model resulting from PLS-SEM. All paths are significant as well. We can see it's very similar to the last one. So comparing the two result models and combining with existing theories from literature, we grouped these factors into extrinsic motivational factors such as perceived usefulness and ease of use of the e-learning system, and intrinsic motivational factors such as self-efficacy and attitudes towards school, and mediators such as learning and reading experience. Consistently, we found that extrinsic and intrinsic motivational factors work together on continued use intention, and mediators mediates the effects of the two groups of factors. Among them, visual attractiveness and reading experience have a direct and strong effect on continued use intention. From our findings, there are some implications for design of e-learning system to address dyslexic users' needs to improve their motivation to engage with e-learning system. In other words, we should apply corresponding strategies to e-learning systems to address all the factors in our motivation model. More references can be found in these papers. The first one is the TiiS paper I'm presenting today. The second paper shows how I developed a classification model for motivation assessment using eye tracking data. The third one describes a software prototype that can provide personalized feedback based on one's motivational states assessed by eye tracking data in real time. Thank you very much.